Hi to all, and welcome to this presentation. My name is Iraklis Saroudakis, and I'm a member of the Oracle Labs Parallel Graph Analytics team. After learning about the power and usefulness of graph analytics and graph pattern matching, you're going to see them in action in an example taken from a real-world use case, in a money laundering detection example. Let us go on ahead and take a look at how our example bank property graph that we're going to use looks like. At the top, you can see the customer vertices that belong to the bank. Then in the middle, you can see the vertices that are labeled accounts. And at the bottom part of the graph, you can see the vertices that are labeled as external entities. And these are basically customers of other banks with whom the internal customers of this bank transact with. And there are also the edges, the different edges that are in the graph. For example, the red edges signify which customer holds which account, and the purple lines that signify which transactions are happening between either two accounts or an account and an external entity. Now let us go on and see the pattern of money laundering that we would like to detect. Let us assume that customer 1 would like to launder money through an external entity to another customer of the bank. Now these two customers seemingly appear different. However, they can be the same person. How can we realize that? We can augment the graph with additional edges that signify whether two vertices share common information. For example, here you can see a common address edge, which means that these two vertices have the same address property, or a common password edge, which signifies that two vertices have the same password property. Now with these edges, you can see that the suspicious money laundering cycle is now forming between customer 1 and customer 2. So there is, from customer 1, there is an edge of common address to account 1. Then there is a transaction through an external entity into this account of customer 2, which is connected to customer 2 through another common address edge. And then there is a common password edge that connects one account of customer 1 to the account of customer 2. And this suspicious money laundering cycle is what investigators are looking for, and then they analyze it further in order to see if it is a legitimate money laundering cycle. Now, graph analytics gives us the tools that are needed in order to find, analyze, and visualize such patterns in a graph. For example, if I would like to write a PGQL query in order to capture and find such cycles in the graph, it could be abstractly expressed as it is illustrated here on the right-hand side of the slide. I would need to capture a customer 1 vertex that holds an account through which a transaction is happening to an external entity back into an account 2 that is held by a customer 2. And the important bit that I would also need to capture is that there is a path of common information between customer 1 and customer 2. And this path can be with as many hops as it can be with one edge or two edges or with more edges. And these edges are edges of common address as common password that we talked about before. Thus, you can see that easily with a PGQL query that we're going to see in the demo, how graph technology can help financial investigators find, analyze, and visualize such patterns in the graph.
Right, so now let us go on with a practical demo with Oracle Graph Studio on OCI Cloud with ADB and PGX to see how this money laundering detection example works in practice. So I've launched Graph Studio here, where I've created a notebook to realize this money laundering detection example. For those of you who are not familiar with Graph Studio, we have another set of training videos you can take a look at. But in short, it's a notebook platform that gives us the possibility to write paragraphs in multiple programming languages and analytics tools such as PGX. In this case, I have created two markdown paragraphs at the top of the notebook that summarize the slides we've seen so far and also depicts, again, the pattern, the example pattern that we're looking for in our example graph. Also, I have used the graph modeler to model a PG view from vertex and edge tables in the ADB that represents the customers, accounts, and transaction edges of the example graph, and loaded the graph in PGX memory. Here, I have a PGQL paragraph that issues the PGQL query to PGX that finds the patterns and returns them and visualizes them. And finally, here, there is a PGX Java paragraph for drilling down on what is the path of common information of the two customers of the example that we are going to see. Now, let us begin by taking a look at how the PGQL query looks like. First, we define here how the path of common information looks like, and it is basically a path of edges that are labeled as either common password or common address. And then we select here all the patterns that match the following criteria. First, we have a vertex that is labeled as customer, and we assign the variable customer1 that is connected through an edge that is labeled as holds into another vertex that is labeled as account, and we denote it with a variable name account1. And we do the same for customer2 that holds an account2. And then we say that we would like a transaction edge between account1 and customer2 wires that is connected through an external entity vertex and another transaction edge into account2. And finally, we would like to say that there is a path of common information between the two customers, and this means an unlimited path of as many edges as they can. And this common info is as we have defined it above. And finally, we constrain the query by adding a filter that account1 should not be exactly the same vertex as account2. Now let us go on and execute this query and visualize the result. Here are the results. We have also used Graph Studio's highlights in order to differently visualize the vertices and the edges depending on their types and properties. So here you can see a customer 1, right, that holds account 1 here, right, and has transactions through an external entity into the account of customer 2. Right, and you can see here that there is a path of common information between the two customers. Further, if you right-click, you can also see the properties and the details of accounts and edges, like this. Now, let us execute the next paragraph for drilling down on what is the path of common information between the two vertices. Just to summarize the code and not explain it in detail, what we do is that we get the two customer vertices in question and we run a Dijkstra shortest path PGX algorithm between them with a filter of common information on the edges of the shortest path. And finally, we will visualize the returned path with a PGQL query and show it. Now, let me run this paragraph and we can see the result. You can see that customer 1 holds an account 1, which is connected through an edge of common password to the account of customer 2. And this concludes the demo and the presentation that shows how valuable and powerful graph technology tools are in the financial domain, for example. Thank you very much.